everyone, I'm Dr. Sandeepa Biswas and you are watching my channel Icons on Earth. I could not upload videos on this channel since last few days because I was sick, but I'm absolutely fine now. And in this video, I'm going to describe the Cobb Douglas Production Function, and I will focus only on the average and marginal product of the factors in Cobb Douglas Production Function. And I will explain it through my notes, so let's come over it. In this video, I will focus on the concept of Cobb Douglas Production Function and the average and marginal product of the factors of production. So what is Cobb Douglas Production Function? First of all, originally the Cobb Douglas Production Function was applied to whole manufacturing industry. It was not for only some particular product. It was applied on the whole manufacturing industry. Okay, so this is important. There are two inputs, labor, L for labor and K for capital. The CDP, I have written CDP as Cobb Douglas, shorthand for Cobb Douglas Production Function, takes the following mathematical form as Q is equal to A L alpha K beta. So what does Q is suggesting? Q is showing the manufacturing output, L is suggesting the labor employed in the industry, and K for capital employed, total amount of capital employed. A and alpha are positive constants. Okay, A is the constant and alpha is also a positive constant. CDP function found that, or the Cobb Douglas Production Function found that about 75% of the increase in manufacturing production was due to the labor input and the remaining 25% was due to the capital input. Okay, if there is a 100% increase in the output, 75 was due to labor input and 25 was due to capital input. Originally, the sum of the exponents are the alpha and the beta. Okay, the sum of the exponents of Cobb Douglas Production Function was equal to 1. That means alpha plus beta was equal to 1. Later, it was found that it can be greater than 1 or less than 1. Okay, so initially it was found that when the empirical study was conducted, it was found that the summation of alpha and beta will be 1, but later on it was found that the summation of these exponents can be higher than 1 or less than 1. What does that mean? If it is higher than 1, there is increasing returns to scale, and if it is lower than 1, it means it is decreasing returns to scale. Okay, but here we are talking about the basic Cobb Douglas Production Function, that is homogeneous production function of first degree. It was alpha plus beta is equal to 1. And what does that mean? It means that there will be a constant returns to scale, and the figure for this will be like this. On the y axis is capital, on the x axis it is labor, and here are your isochons, like 100 isochons of 100 output units of output, isochont of 200 units of output, likewise 300 units of output and 400 units of output. Okay, so you can see that the distance between all the isochons is equal. Okay, so to have a 100% or 1 unit increase in the output, you need to increase 1 unit of the total factors of production. Okay, So, the ratio or the proportion is equal of the increment in the factor combination and the resultant output. Okay, so it is called constant returns to scale. Okay, so the proportion doesn't change. Proportion of output and input doesn't change in this particular form of production function. Now, as I said, I will talk about the average product and marginal product of the factor in Cobb Douglas production function. It is one of the essential features of this production function. So, the average product of factors in Cobb Douglas production function, you can write it as you know, Cobb Douglas production in Cobb Douglas production function, Q is equal to A L alpha K 1 minus alpha. So, what is 1 minus alpha? You can write beta as 1 minus alpha also. Okay, because the summation of that alpha and beta is 1. Okay, so you can write beta as 1 minus alpha. It will give the same expression, right? So, now you know that average product of labor is equal to Q upon L. You know that to have average product of labor, you divide the total output upon the total number of labor employed. Okay, so here on the numerator you have written the equation of Q, that is this one, right? You have written it as it is, and you put it the L here. Okay, now you solve this. You put bring A outside the equation, and K by L, you write K by L, and you bring this alpha in the denominator, and it becomes 1 minus alpha. So, you can put it in the bracket and write 1 minus alpha for this fraction, and you got the expression for your average product of labor. Now, what you can see written by pencil on this screen is the average product of capital. Likewise, average product of capital will be Q upon K. You have written the equation of Q here, and you have put it K here. Okay, now you brought this K on the numerator side, and it has become minus 1, exponent of minus 1. You put minus 1 here to 1 minus alpha minus 1. Okay, you can see here. Okay, or you can write it as AL alpha K minus alpha, as the plus 1 and minus 1 has been cancelled out, or you can also write it as AL alpha K beta minus 1. So, you get the expression for average product of the capital. Now, if we talk about the marginal factor in Cobb Douglas production function, then you can you know that you write marginal product of labor as delta Q upon delta L, and it will be, when you differentiate Q with respect of L, you get A alpha L alpha minus 1 and K 1 minus alpha, because it will be the same. I am assuming that you know how to differentiate, and when you solve this, putting this L in the denominator, you get this Okay, so you are bringing this L from here and putting here. So minus 1 has been cancelled out, and k minus k exponent 1 minus alpha is written like this. So further, you when you simplify it, you write as a alpha L exponent alpha minus alpha and k 1 minus alpha, and in the denominator L 1 minus alpha. You have put it this minus alpha and minus alpha from your own to cancel out this L. Okay, so a now what you have a alpha k 1 minus alpha upon L 1 minus alpha, and when you simplified it, you get a alpha under bracket k minus L exponent 1 minus alpha. So this is the expression for marginal product of labor, and here I have written the marginal product of capital by solving these process for marginal product of labor capital, and it will be beta a L alpha k beta minus 1, and here if the average product of labor is greater than marginal product of labor, a k upon L, that you have written the equation of the average product of labor, and here the equation for marginal product of labor. So the average product of labor is higher than the marginal product of labor. So I hope you understood, and this video is beneficial for you. I hope you like the video. Please share and subscribe my channel, and good luck for your studies. Stay safe. Bye bye.